Assalamualaikum and selamat sejahtera. My name is Muhammad Imam ISMAIL and my metric number is B0920100266. So today my friend and I want to give a presentation about conduction graphical analysis on heat transfer. So this is our group member. So why it is called heat sink? Heat sink is a substance or device that absorbs or dissipates especially unwanted heat. So in a heat sink, they use fin surface. In the study of heat transfer, fins are surface that extend from an object to increase the rate of heat transfer to or from the environment by increasing convection. So there are four types of fins, which are straight fin, radial fin, annular fin, and pin fin. And its main application are in industrial facilities, power plants, solar thermal, water system, hatchback system, and many more. So this is our first selection of fin design 1. This is straight type of fin, but we have upgraded it by punch a 20 holes through it. The base length is 40 x 40 mm width. The fin is 10 mm height from the surface, and the thickness is 1 mm. The hollow is 1 mm width and 10 mm deep. The diameter for the hole is 2 mm. For the selection of fin design 2, we choose to make a pin type of fin design. So the base still the same, 40 x 40 mm width, and for the pin height is 10 mm, the diameter is 2 mm, and the hollow is 2 mm width and 10 mm deep. As you can see here, this is our analysis for the two type of fin that we have been designed. So for the design one, as you can see, the lowest temperature we get is 56 Celsius, and the highest temperature is 56.2. And for the pin type design 2, we get the lowest temperature is 77.9 and the highest temperature is 78.1. From our analysis, we can see that design 1 have low temperature than design 2, which means it can dissipate more heat. As you can see from the right, this is our data that we put to run for this simulation.
Assalamualaikum warahmatullahi wabarakatuh. My name is FATINI binti ABDUL. My matrix number is B0920100107. And for this video presentation, I will explain about the discussion for this video. For the first design one is the area is 40 x 40 mm, and the height for this design is 10 mm, and amount of fin is 20. It is contains with 20 fin with distance 1 mm. The temperature is lower compared to the design 2 because it have more fin and the greater heat removal. When the smaller value of distance between the fin, the effectiveness for the fin will be greater. And then for the design 2, area for this design 2 is also the same to design 1, 40 x 40 mm, and for the height also the same, 10 mm, and amount of fin is 130. It contains 130 fin with distance between the fin is 2 mm. The temperature is higher compared to design 1 because the more heat remains in the sink. When the bigger value of distance between fin, the effectiveness will also be lower.
Assalamualaikum. My name is AIMAZARITH IMRAN bin Muhammad RIZAL. My matrix number is B0920100090. I will continue this presentation with discussion of this assignment. So the first one is to make the temperature lower, we can increase the length and the surface area. Then by increasing the amount of fin, the heat transfer from a surface will also increase. When the fin have high value of thermal conductivity, later the temperature of a surface will be equal to that of body. Fin efficiency is the ratio of fins actual removed remove heat with the amount of heat that are able to be removed if the wall fins have the same temperature to the fins base. Next is the higher value of convective heat transfer coefficients, then the value of fins efficiency will be lower. Another factor that will affect the efficiency of fin is the material of the fin. The rate of heat transfer is inversely proportional to the thickness of the fin.
So for the conclusion, in summary, we make two different designs with different amount of fin. It is to study heat transfer between two different designs. We can conclude that to make temperature lower, we need to increase the length and the surface area. When the fin have high value of thermal conductivity, later the temperature of a surface will be equal to that of body. Moreover, based on design 1, we can conclude that the temperature is lower compared to design 2 because it has more fin and the greater heat removal. It is because when the smaller value of distance between fin, the effectiveness will be greater. Therefore, it is proven that by using different amount of fin, we can differentiate the rate of the heat transfer. So that's all from our group. Thank you.